So we've now spent quite a bit of time building up even more tricks we can use to help us solve trigonometric equations. So we've learnt the addition and subtraction formulae, the double angle formulae, other multiple angle formulae. For example, we saw some formulae for tan 3 theta and so on. And we're going to use all of that stuff we've done to help us solve other kinds of trigonometric equations that previously we couldn't solve. So let's just start with this example. So the question is solve 4 cos of theta minus 30 degrees equals 8 root 2 sine theta for theta between 0 and 360 degrees. So what we can see is we've got cos of theta minus 30. And we know one of the things we can do with this is to use the cos A minus B formula to expand it. So in our solution, the first thing we can do is we can say this equation, if we use the cos A minus B formula, which is cos A cos B plus sine A sine B, the equation becomes 4 lots of cos theta cos 30 plus 4 lots of sine theta sine 30 equals 8 root 2 sine theta. And then cos 30 is root 3 over 2, so this is 2 root 3 cos theta. And sine 30 is a half, so this is 2 sine theta equals 8 root 2 sine theta. And then we can gather all the sine thetas together on the right-hand side. And then if we divide by cos theta, that will give us an equation we can solve, because sine theta over cos theta is tan theta. So therefore we get tan theta is 2 root 3 over 8 root 2 minus 2. And then to solve this, this number is a positive number, so you can check that on your calculator. So our solutions are going to be in the A and T quadrants. And we know, so if you do tan inverse of 2 root 3 over 8 root 2 minus 2, that's tan inverse of 0.37 something, we get an answer of 20.4 degrees. And then, so that's over here. And then for the next one in tan, we can just add 180. So the other value is 200.4 to 1 decimal place. And we're done. Okay, so let's see another example then. So this time we're asked to solve 2 tan 2y tan y equals 3 for y between 0 and 2 pi. So we can start by observing, and let's say, give answers to 2 decimal places. So we know a formula for tan 2y. We can use the double angle formula. This is 2 tan y over 1 minus tan squared y. So therefore the equation becomes 2 tan y times 2 tan y over 1 minus tan squared y equals 3. And this kind of second 2 tan y here is from this stuff in red. So this is the same as 4 tan squared y over 1 minus tan squared y equals 3. And then if we multiply both sides by 1 minus tan squared y, we get 4 tan squared y equals 3 minus 3 tan squared y. So 7 tan squared y is 3. So tan squared y is 3/7. And therefore we can say tan y is plus or minus the root of 3/7. It's important to remember the plus minus. Sometimes people forget that. So we're expecting solutions in all 4 quadrants. we can find one solution for y by looking at tan inverse of root 3/7. And we need to be in radians because we're between 0 and 2 pi. And we should get 0.58 to 2 decimal places. So that gives us a solution here. We can find the other one where tan is positive by adding pi. So the next one is pi plus 0.58, which is 3.72 to 2 decimal places. And we can find even more solutions by doing tan inverse of minus root 3/7, which will give us minus 0.58. And then again, we can add pi, we can add 2 pi. The minus 0.58 we don't need, but when we add pi and 2 pi, that will give us the two solutions in S and C. So this solution here we don't need, because we're only between 0 and 2 pi. So therefore, all the values of y are 0.58, pi plus 0.58, which is 3.72, pi minus 0.58, which is 2.56, and 2 pi minus 0.58, which is 5.70, all correct to 2 decimal places. Okay, let's do another example. So this time we want to solve 3 cos 2x minus cos x plus 2 equals 0 for x between 0 and 2 pi. So this time again, we're going to use a double angle formula for cos 2x. So recall that cos 2x, well, there are lots of formulas you can use, but notice because we have a cos x here, it probably makes sense to write cos 2x solely in terms of cos x. So the best formula to choose would be 2 cos squared x minus 1, because then we'll get a quadratic in cos x. So the equation is going to become 3 lots of 2 cos squared x minus 1 minus cos x plus 2 equals 0. And then if we expand the brackets, we've got 6 cos squared x minus 3 minus cos x plus 2 equals 0. And that's equivalent to 6 cos squared x minus cos x minus 1 equals 0. And then observe you can solve this either using the formula or simply notice that it factorizes. So from this bracket we get cos x is minus 1/3, and from the other bracket we get cos x is 1/2. So for cos x equals minus 1/3, we're going to get solutions in S and T. And for cos x equals 1/2, we're going to get solutions in A and C. So let's start with cos x equals 1/2 first, because we can do that without a calculator. Cos inverse of 1/2, you probably remember from GCSE, is pi by 3, or 60 degrees. So this one's pi by 3. So to find the one in C, we're going to do 2 pi take away pi by 3. Because 0 is the same as 2 pi in this diagram, which of course is 5 pi by 3. And then for minus 1/3, we can use our calculator to do cos inverse of minus 1/3, which is 1.91 radians. And then the other, so that's the solution in S. And then the other solution, there are a couple of different ways to get it. Probably the easiest way is to do 2 pi take away 1.91, but maybe a better way to understand what's going on is this is pi here, so whatever the gap is between 1.91 and pi, that's what we need to add to pi to get the solution in T. So this second solution you can also get by doing pi plus the difference, the gap between pi and 1.91. And that will give you the same thing. Okay, so we have our four solutions, so we can say therefore x is pi by 3, 1.91, 4.28, or 5 pi by 3. And for our final example, the question is part A, prove that sine 3 theta equals 3 sine theta minus 4 sine cubed theta, and part B, hence or otherwise, solve 16 sine cubed theta minus 12 sine theta minus 2 root 3 equals 0 for theta between 0 and 2 pi, giving exact answers. So this thing about exact answers, that in the context of trigonometry often means in terms of pi. So, because we're working in radians, so probably as multiples of pi. Okay, so on to the first part then. To prove this, we're going to do a very similar thing to what we did in the previous video. Sine 3 theta is the same as sine 2 theta add theta. And then we know a formula for sine A plus B. So the formula is sine A cos B plus cos A sine B. And then we know a formula for sine 2 theta. It's the same as 2 sine theta cos theta. And we know a formula for, well, we know three formulas for cos 2 theta. Since we want an answer in terms of sine theta, the most convenient one to use would be 1 minus 2 sine squared theta. It won't really matter if you use one of the other ones, but you'll end up at the end having to convert everything in terms of sine theta. So we've got 2 sine theta cos squared theta. And then if we expand the brackets here, we've got sine theta minus 2 sine cubed theta. And this is looking pretty good, but in the answer we only have sine thetas. So we need to convert the cos squared into a sine squared. So we can replace it with 1 minus sine squared theta. So this is equal to 2 sine theta, 1 minus sine squared theta, plus sine theta minus 2 sine cubed theta. And then if we expand the brackets again, we've got 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta, which is 3 sine theta minus 4 sine cubed theta as required. And then in part B, we're asked to solve an equation. The equation is this. So let's solve this equation. And notice that this bit looks kind of similar to this thing here. So notice if we multiply the thing I've just circled in red by minus 4, we would get this thing here that I've underlined. So this thing we can replace with minus 4, and this was equal to sine 3 theta. So this is minus 4 sine 3 theta. Minus 2 root 3 equals 0. Whenever you have a question that says hence or otherwise, the best way is probably the hence in almost all cases. So hence means using, it means therefore, so it means using part A. So the easiest way is then to solve this equation. So if we move 4 sine 3 theta to the other side, so we can say therefore sine 3 theta is minus 2 root 3 over 4, which is minus root 3 over 2. And we wanted to solve between 0 and 2 pi. So actually this is really nice because it can be done without a calculator. So sine 3 theta is negative. So our solutions for 3 theta are going to be in the t and c quadrants. If we do sine inverse of minus root 3 over 2, then we're going to get this, well, I think the calculator will give minus pi by 3. But what we want to do is then find the solutions between 0 and 2 pi. So it will give us minus pi by 3 down here. But then, so the first positive solution will be pi add pi by 3, which is 4 pi by 3. And then the solution, the first positive solution in C will be plus 5 pi by 3. So 3 theta is 4 pi by 3 or 5 pi by 3. And remember, we need to keep going because we know theta is between 0 and 2 pi. So 3 theta is between 0 and 6 pi. So we have to keep going round. So the next time, so pi is also the same as 3 pi. So the next solution in t, we can add 2 pi to 4 pi by 3. So if we add 2 pi, we're going to get 10 pi by 3. If we add 2 pi to this, we get 11 pi by 3. And then we just need to keep going one more time, and we'll get 17 pi by 3. And, oh, sorry. Well, we'll get 16 pi by 3 and 17 pi by 3. And that's all of them. And now we can say, therefore, theta is all of these divided by 3. So that's 4 pi by 9, 5 pi by 9, 10 pi by 9, 11 pi by 9, 16 pi by 9, and 17 pi by 9. And note that you can't convert these into decimals because the question is very clear that you have to give exact answers. So we have to leave things in terms of pi. So this is a reasonably difficult question. There are a lot of places you could go wrong, and this really relies on having a strong foundational knowledge of the year 1 trigonometry, solving equations like sine 3 theta equals minus root 3 over 2. Okay, so that concludes this video.